We just did a little demonstration once again with the slinky to demonstrate something different this time. Phenomenon called interference. We saw just a minute ago that when a crest hits a crest, they go right through each other. It's as if they never touched each other. But for that brief moment where they are going through each other, we get a phenomenon called constructive interference. The crest doubles in size. One crest, another crest, we get one crest that results from those two that is bigger than either of the two were to begin with. That's called constructive interference. If a trough hits a trough, again, they go right through one another. But during that brief time that they're going right through one another, they produce a bigger trough. That's called constructive interference as well. When a crest hits a trough, they kind of cancel each other out. They keep going right through each other as if they never encountered each other. But for that brief time where they're going through each other, we get destructive interference. They cancel each other out. They produce a smaller wave than what we started with. So when you get a bigger wave, it's called constructive interference. When you get a smaller wave, it's called destructive interference. What we're going to do right now is predict what the exact waveform is going to look like at one instant in time as a result of two different waves. So what you see up on the board right now is two waves. We got a smaller wave that's going to the right. We got a bigger wave that's going to the left, although it doesn't really matter what direction they're going. Okay, and that's what you have on the paper in front of you as well. We want to see what the waveform looks like as a result of these two waves hitting each other at this moment in time. Now, a half a second later, these two waves are going to be in different places, and the resulting interference pattern is going to look different. A half a second before, these waves are going to be in different places. The interference pattern is going to look different. But at this moment in time, what does the wave pattern look like? What does the interference pattern look like? We're going to use something called the superposition principle to figure this out. The good news is the superposition principle involves, in its easiest form, adding. In its most difficult form, subtracting. So it should be pretty easy for us. What we want to do to determine exactly what this waveform looks like, again, regardless of which way these waves are actually traveling, is measure the size of the wave, of both waves, at a bunch of predetermined points, and then add the sizes of the waves together algebraically. We got wave number 1 over here, and we got wave number 2 over here. Wave number 1 is the small wave, wave number 2 is the big wave. Until we get to this spot right here, wave number 1 is the only wave that we have. So that's what it's going to look like. There is no interference pattern there, because there is only one wave. There's nothing to interfere with. Over here, we get only wave number 2. There's nothing for wave number 2 to interfere with. So the pattern is going to look like that. But in between there, in the middle, you get two waves crossing each other. You're going to get interference as a result of that. Here's where we have to add up or subtract the size of the waves. Let's take a look at the first wave. Okay, wave number 1. Okay, remember, wave number 1, again, is the small wave. At this point, at this vertical line, right here, the first wave is 2 blocks above the axis. The big wave is about 1 block above the axis, right? See, 1 block above, 2 blocks above. 1 plus 2 is 3. So let's put a little X there. The resulting waveform and that at that moment in time, at that place, will be 3 blocks above. One wave is 1 block above, the other wave is 2 blocks above. The combined waveform is going to be 3 blocks above. So let's go to the next vertical line here, the next grid line. The small wave is 2 blocks above. The big wave is 2 blocks above. We add those up, the resulting waveform is 4 blocks above. 2 plus 2 is 4. Next one. Small wave is 2 blocks above. Big wave is 2.5 blocks above. What's 2 plus 2.5? Oh, there's a toughie because we're dealing with fractions in this one. 2 plus 2.5 is 4.5. You could count on Zach to get that one. 4.5 above. Good work, Zach. So we draw the next little X 4.5 blocks above. Small wave is about 2 above. It's just a little bit less than 2, but close enough. Then the next one is about 3 above, just under 3. 2 plus 3 is about 5. Going to be almost 5 here. 1.5 plus 3 is about 4.5-ish. 1.5 plus 3-ish is about 4.5 again. This one's just over 1, just over 3. 1.25, 3.25, that's about 4.5 again. This one's a half above, a half a block above, 3.25, about 3.75 above. It doesn't have to be perfect here. You just want it to be close. So what's this wave going to look like? When these two waves encounter each other, for that brief moment in time that we're showing up on the board right now, you will get this wave pattern produced, this interference pattern produced. The first part of the small wave, unchanged. The last part of the big wave, unchanged. But where they intersect with each other, you get a bigger wave. What kind of interference is that? What do we call that? Constructive or destructive interference? When we make a bigger wave as a result of two crests or two troughs, we call it constructive interference. You're constructing something, you're building something, you're making something bigger, not destroying it, making something smaller. Yeah, we can pop the next one up here. Again, we got two waves here, a small wave and a big wave. We'll call them wave number 1, wave number 2 again. The big wave and the small wave. Doesn't really matter which way they're going. We could say wave number 1 is going this way, wave number 2 is going this way, but it doesn't really matter. Okay, the movement of them is irrelevant. We're freeze framing this at one moment in time, one brief moment in time. What does the wave pattern look like at that brief moment in time? Well, until about this point, it looks like this, because there's nothing for wave 1 to interfere with at that point. Over here, it's going to look like this, because there's nothing for wave 2 to interfere with. But in between there, where we have two waves in the same place, there's going to be interference. Wave number 1 is 2 above. Wave number 2 is about 1-ish below. Where do you think we're going to put the X? Bruce? About 1 above. Right? 2 subtract 1, or 2 plus negative 1 gives me 1. Wave number 1 is 2 above. Wave number 2 is 2 below. What's 2 plus negative 2, or 2 subtract 2? Now it gets hard, right? Adding negative numbers? Goodness. What's 2 plus negative 2? I'm going to go back to Zach on this one because I know he's good with math. 0. That's what teachers do, right? They always go back to the smart kids. Zach knows what 2 plus minus 2 is. Two above, 2.5 below. What's that one going to be? Yeah, it's going to be negative 0.5, right? 2 plus negative 2.5, or 2 subtract 2.5 gives me negative 0.5. About right there. Doesn't have to be perfect. Right, Jacob? Doesn't have to be perfect. Just close. 2 above, 3 below. 2 plus negative 3 gives me negative 1. Almost 2 above, a little bit more than 3 below. If you take away 2 from the bottom one, it's going to be about negative 1.25-ish. 1.5 above, 3.5 below. Going to be about -2. 1 above, 3.5 below, about -2.5. A half above, 3.5 below. 0.5 plus -3.5 gives me about -3. So what does it look like on the left-hand side before these waves hit each other? Well, it's the blue pattern that you see there. What does it look like on the right-hand side for the second wave before they hit each other? Well, it's what you see in green there. What does it look like at that brief instant in time in the middle where they're intersecting with each other, where they're crossing each other? Looks like this. So if we scratch out this, and we scratch out this, these two waves that are separate waves for that brief moment in time would look like this. What do we call that? It's interference, right? But what kind of interference is it? It's destructive. It's like we're destroying a wave, right? We're making a smaller wave. It's not constructive interference. When you're constructing something, you're making something bigger. Destructive interference is when you're making something smaller. And that's what we got here. Destructive interference. That make sense?